So this is going to be just the introduction to Unit 10, which is all about conics, which probably means nothing to you at the beginning. So first we do kind of it's going to seem like a review of something we've done before, but so here's the idea, the quick graphing review. You've learned the equations and the graphs that go with many of the basic functions. Remember, we talked about all the different parent functions. Well, on this page, we've got basically all 8 of the parent functions that you've learned this year. Well, I guess 1 or 2 of them you actually learned in previous years. But if you put all of the graphs together that we've talked about this year, you have it right here on this page. So let's think through. The first one, remember the basic parent function is, we might write it just y equals x. I'm actually going to extend it a little bit to say that as it gets moved around, when we first learned about the line, remember we thought of it as mx plus b. So that'll represent any line, no matter what the y-intercept is, no matter what the slope is, right? The generic one that you're looking at is actually just y equals x because the slope is 1 and the y-intercept is 0. But then we had the basic parabola, and the basic parabola was just y equals x squared. And I know you can put other numbers on there that'll move it left or right or up or down or flip it around, but that's the basic parent function. Number 3, you may or may not remember, is the cubic function. And what would really be good right now is I've gotten you started. Can you go on through 4, 5, 6, 7, and 8 and fill out the rest of those just to kind of see if you remember them? Because this is kind of our review. In some ways, it's kind of a review for your exam, but it's a summary of some of the things we've done this year. So maybe see if you can fill those in, pause the video, and then come back and see how you did. That's what will really tell you if you did it correctly. And then the last 2, those are the ones we just did in Unit 9. So remember, this is the basic exponential. And the way I'm going to write it is something like b, if I could get b to the x, right? So it might be 2 to the x, or it might be 3 to the x, or it might be 5 to the x. Remember, we said it doesn't really matter what number the base is. That what's in common is that the exponent is always x. So it could be any of those generically. And then the last one, remember, that's our log graph. And again, it doesn't matter what the base is on the log. I'll just say log base b of x. It might have been log base 2, log base 3, log base 5, whatever. So those are all of the 8 parent functions that you should know at this point. Okay, so we're not going to do another unit that is just completely a review, but we're going to just kind of take it a little bit of a step further. Now, this next page is taking all of these parent functions that we've learned. And so this next page is just a review of what happens when you move them up or down or left or right or whatever. So again, this is kind of like a homework page, but this would be a good page for practice to make sure you remember all the different ones. I think I'll go in and point out a couple of them, and then you should definitely finish filling them in based on what we had talked about. So like, for example, we know that, let's look at number 2. We know that this is a square root graph. So remember, look at the previous page, the square root graph. If I'm just drawing the basic, remember it's doing this kind of thing. But what does that negative out in front do? Well, the negative is going to flip it across the x-axis. So now it's going to be going this direction, right? Now it's coming down that direction. And then if there's a plus 3 out at the end, what does that do? Well, doesn't that move the entire thing up 3? So what was at the origin is now up here, and it's going that direction. So there's your square root graph that's been flipped over and moved up 3. Or maybe we look at number 4. Okay, remember number 4 is that 1 over x graph, right? That rational function. And so if I think about where the asymptotes normally intersect at the origin, I'm going to move this whole thing 1 unit to the right and 1 up. And so remember, that tells me kind of where my new asymptotes are going to intersect. And then remember what the 1 over x graph looks like, that you use those asymptotes to give you an idea of how wide the graph goes. Or you might say, hey, look down at number 9. Well, remember the basic exponential graph. I know this is exponential because it's 5 to the x. Remember the basic exponential graph levels off at the x-axis, right? Comes through that point on the y-axis and then goes up. Well, that negative that's out in front, remember the negative out in front flips it across the x-axis. So instead of going through +1, it's going to be going through -1. And if you can imagine folding it over on the x-axis, it's going to do something like that. Okay, so all the rest of these are just the different graphs, like maybe we'll label them. Hopefully you can tell this is that cubic graph, right? You've got your square root graph, you got your parabola. This is that exponential graph, right? Or remember, this is your log graph. Remember, it does this. That's just your basic pairing function. Or number 8, you got another parabola. So those are the basic ones, and you're just going to move around. Okay. The next thing we're going to do is we're going to kind of make a connection. All right. Well, that's not the only graphs there are in the world. Take a look at these. You might be saying, okay, well, we've already done parabolas, right? This first one is a parabola. So why do I bring that up again? Well, we've done parabolas that open up or down, but maybe parabolas, could they open to the right or to the left, right? So maybe we think about parabolas opening right or left as opposed to just up or down. That would be different. Or the next one, we know this is a circle. In geometry, a lot of times you deal with circles, but I don't know, do you graph circles? I don't really remember. Do you talk about what would make that circle maybe move over here, and be centered over here? What might make that happen? Or I know one graph you haven't talked about, or this next one, it's not an egg, it's not an oval, it's called an ellipse. Not an eclipse, but an ellipse. Right, so it's kind of circular-ish, but it's kind of flattened. But maybe your ellipse isn't going that direction. Maybe it's going more, okay, that's a terrible ellipse, sorry. Maybe it's going more that direction, something like that. But you see what I'm talking about. Let's see, this will help me. Maybe it's going something like this. Okay, something like that. So it's elongated that direction. This last one, I know you haven't done this kind of a graph before. It's called a hyperbola, not hyperbola, as some people want to call it. Okay, so that's what a hyperbola looks like. It's kind of like these two pieces that reflect each other. But how else might you see a hyperbola? Well, notice these kind of open left and right. Well, maybe you have a hyperbola that opens up and down, something like this. So even though it's a similar shape, it's opening a different direction. So that's where we're going in this next part of Unit 10.